Okay, so I'm going to do two exercises from 13.8, finding relative extrema. First one I'm going to do is finding and classify the critical points of f of xy equals x squared y squared. This is from the book 13.8, number 11. So critical points are where both partial derivatives are equal to 0, so we're going to want to find the partial derivatives first. So f sub x of xy is equal to 2xy squared, and then f of fy of xy is equal to 2x squared y. So setting both of these equal to 0, we get 2xy squared equals 0 implies that either x equals 0 or y squared equals 0, which just means y equals 0. And then over here we have 2x squared y equals 0 implies that either x squared equals 0, so x equals 0, or y equals 0. So since x equals 0 makes both partial derivatives equal to 0, the entire line x equals 0 in the xy plane is going to be critical points, and the same thing with y. Since y equals 0 makes both partials equal to 0, the entire line y equals 0 is going to be critical points. So critical points are all points on the lines x equals 0 and y equals 0. So to classify these, we're going to want to do the second partials test using the determinant to find what type of critical point this is, either an extrema or a saddle point. So to do that, we have to first find the second partial derivatives. So the second partial derivative with respect to x is 2y squared, because the first f sub x of xy is 2xy squared. And then the mixed partial is this with respect to y, so 4xy, and then the double y one, f sub yy of xy, is equal to the derivative of this with respect to y, which is just 2x squared. So I like to put the determinant in a general form like this, just so it's easier to evaluate at multiple points. So it's equal to this times this, so just 4x squared y squared, and then minus this squared, 4xy squared, which is just 16x squared y squared. If you notice, all the critical points are either x equals 0 or y equals 0. So if either of those things are true, then this right here goes to 0, and so does this, which means the whole thing will be equal to 0. So the second partial test is always inconclusive for these points, because if it's the determinant is equal to 0, the test is inconclusive. But we can still determine what type of point it is, because the function is f of xy equals x squared y squared, which is the product of two squared terms, which means it's always greater than or equal to 0. So the minimum value is going to be 0, which is achieved at at all the points where x equals 0 or y equals 0. Just write that. Let's spell that. Okay, so therefore all these critical points are relative minima, but they're actually absolute minima, but I mean, it doesn't really matter for this problem. Okay, so the second problem I'm going to do is this one. It's the same type of problem, except the second partials test will work for this one. So again, we're going to want to find the first partials here. So f sub x of xy is equal to 2x minus 2xy, which is just equal to 2x times 1 minus y if you factor out the 2x, which will be important to find the zeros. And then f sub y of xy is equal to 4y minus x squared. Okay, so if you set this equal to 0, that means that either 2x or 1 minus y is equal to 0, which means either x equals 0 or y equals 1. And if you go over here and say x equals 0, that implies that 4y is equal to 0, so y equals 0. So if you say y equals 1, that implies that 4 minus x squared equals 0, so x is equal to positive negative 2. So the critical points are 0, 0, 2, 1, and negative 2, 1. So if we do the second partial test again, we need to find the second partials, which is just, this one is the partial derivative with respect to x of that, so it's just 2 minus 2y, and then f sub xy of xy is equal to negative 2x, and f sub yy of xy is equal to 4. So, because that's the derivative of this with respect to y. So the determinant of xy is equal to 4 times 2 minus 2y, which is just 8 minus 8y, and then minus this squared. So minus 4x squared. So the determinant at 0, 0 is then equal to 8, because 8 minus 8 times 0 minus 4 times 0 is it's just 8, which is greater than 0. And then f sub xx at 0, 0 is equal to 2 minus 2 times 0, which is just 2, which is also greater than 0. So it's concave up in both directions there, which means that this is a relative min at 0, 0, and then f of 0, 0, which is 0 plus 0 minus 0, which is 0. The determinant at 2, 1, I believe, yeah, is equal to negative 16, because 8 minus 8 is 0, and then minus 4 times 2 squared is negative 16, which is less than 0. So there's a saddle point here at 2, 1, f2, 1, which is 4 plus 2 minus 4, so 2. And that's going to be the same z value as negative 2, 1, since both x terms are squared. So the determinant of negative 2, 1 is also equal to negative 16, because again the x term right there is squared, so that's less than 0. So there's a saddle point at negative 2, 1, 2. And I think that's everything.